Aggregate functions are ideal for getting high-level summaries of financial data. That's because in a typical relational database, sales numbers are recorded individually. You might have a total profit for each store recorded on a daily basis. Using aggregate functions, you can find total profit for the week, or the month, or for all sales within the same sales region. To do that, you only need to group your data into different buckets. Let's take a look at information in the AdventureWorks database that is stored in the sales order detail table, down in the sales schema. We can find that table right here. If you expand it, you'll see different columns, but it is easier to create a new query. I'll write a simple query that says select star from sales.orders detail. In the first column that's returned, I can see that we have a number of rows that all correspond to the same sales order ID. Let's move this up on screen a little bit, and I can see that all of these records starting at number 1 and going down to number 12 all correspond to sales order number 43659. Each row on this table represents a line item on the order. Over here, we have a column for the order quantity and the products that were ordered for each line. Then I have the unit price of each product, and if I scroll over here to the far right, I can find the line total for each line in the order. Now we can use a group by clause in the query to group all the records in this table together based off of the common sales order ID numbers. Then for all the rows that correspond to each sales order, we can summarize all of this information to give us a sum total for the amount of order, or give us the number of items that the order contained, or count up the number of unique items that were ordered. Let's go ahead and modify the query about to do that. First, I need to be more specific about what columns I want to return. Instead of select star, I'm going to start with the sales order ID column. Then I want to see the total value for the order, so I'll use the sum aggregate function applied to the line total column. I'll give this column an alias. I'll call it as order total. I also want to see how many items the order contained, so I'll use another sum function, but this time I will apply it to the order quantity column. I'll give this column an alias as number of items. And finally, I'm going to add one more column. I want to see how many unique items were in each order. For this, I'll use the count function. And I want to count up the distinct product IDs. I'll call this column as unique items. So it adds the columns that I want to see on my query. This is quite pretty long, so I'm going to break it down into multiple lines. We'll select the sales order ID. I'll go ahead and move the sum here down to the next line. And we'll do the same thing for all these other calculated values. So now I can easily see the 4 columns the query will return. So that finishes the select clause. Now we need to remember to group all of the rows together based off the sales order ID. We'll do that after the from clause. Let's execute the query to see the results. Now I have a good summary about every order in the database. I have the total for each order and the number of items for each order, as well as the number of unique items. If you want to see which order was the most valuable, you can add the order by clause to the query. I'll do that after the group by clause. I want to order by the order total column in a descending order. When I execute the query, it reveals the order 51131 had the greatest order total at $163,000. So that's one way we can get an insight into the data. But using grouping and aggregate functions, we can take an entirely different look at exactly the same data. Let's return to the original full data set. I'll go ahead and highlight all of this, and I'll change it back to select star from sales.salesorder The original sales records show us the products that were ordered in this product ID column. And we can also see how many products were ordered with the order quantity column. We can use this data to find some information about the popularity of each product that AdventureWorks sells. I will modify my query to select the product ID column and the sum of order quantity. We'll call this column as total quantity sold. We're going to pull the information from the same table, sales.salesorder but I want to group it by product ID. Then I can order the records of the total quantity sold in a descending order. Execute the query. Oh, it looks like I have a typo here. This order quantity as an abbreviation, not the word spell out. That's better. I'm going to execute it now. And now I can see that the product ID 712 is the most popular product with over 8,000 sales. If we wanted to see more about exactly what this product was rather than just seeing the product ID number, we will need to create a join to the related table, which is production.product table. Let's go ahead and scroll up here in the list and we'll find it there. Inside this table, we can see that we can match the product ID and get the name of the product. Let's go ahead and add this column into our query. I'll come back here and modify the select line first. Now, since we are going to be using two tables, we need to be more specific in the select clause with where each of these columns is coming from. So instead of just select product ID, I need to say select sales order detail.product ID. That will specify that this column is coming out of the sales order detail table. Then we're going to add another column. I'll just move this down here. This will come out of the product table. It will be name column. And finally, I want the sum of the order quantity, but I need to be more specific that this is coming out of the sales order detail table as well. That finishes the select portion. And now I need to fill in the from clause. It's going to be from the sales.sales order detail table, and we're going to do an inner join to the production.product table. The fields that they are related are on sales.sales order detail.product ID is equal to production.product.product ID. And finally, since we added a column to the select clause that isn't used in an aggregate function, we also need to add it into the group by clause. We'll come down to this line, and after group by the sales order detail.product ID column, we'll add in reference to the product.name column. So that finishes the statement, and then we added a little bit more complexity to the query, but hopefully by stepping through the changes, made it easier to follow along. Now let's go ahead and execute the query and see if it works. Now we can see the product name alongside the product ID number, and we can easily see that the AdventureWorks corporate logo cap is the best selling product. And that's a couple of different ways that you can get multiple perspectives on the story that your data is telling by simply putting different groupings and aggregate functions to the same set of input records.